Okay, so this is lesson 3 on page 627. What I want you to do is I want you to box in solving systems. So that's what this entire unit is on, is solving systems. And there's actually 3 methods that we could use to solve systems. The first method was lesson 1 in the workbook, and that was graphing. So remember, with systems, you're always going to be given 2 different systems. And if you were to graph them, the solution to those 2 systems would be the intersection. So graphing is one method. That would be the solution there. And it'd be on your calculator. Students really like graphing. Okay, so if you can graph, you want to graph. The second method of solving is what we're going to do in today's lesson, and it's something called substitution. The third and last method of solving is what we will do tomorrow, and it's called elimination. It's taking the same systems and you're just deciding how do you want to solve it. You will have a preference, especially between substitution and elimination. Sometimes it's like half the class likes substitution and the other half likes elimination. If it is an exam and it's a multiple choice question, you choose which one you're going to use to solve. What's going to happen though on your quiz, which will be on Monday, I do have to test all 3. So I will have one question that says solve the system by graphing. And then I'm going to have one question, solve the system using substitution, and one question, solve the system using elimination. So you do have to know all 3. But if you're not told which method, you choose. Okay, before we start class example number 1, I actually want to add an example at the top. So can you write down for me the first system, y is equal to 2x plus 10. And then the second system is 2x plus y is equal to negative 2. So here's what substitution is. And it might take a couple class examples before you're like, okay, I see what's going on. In this first system, I know what y is equal to. Y is equal to 2x plus 10. So what I could do with this 2x plus 10 is I could find a y in the second system, and I could take that 2x plus 10 and substitute it into that system. So the first system tells me what y is. Y is in the second system. So you take that 2x plus 10 and you put it into the second system. What that would give you would be the following. It would give you 2x plus y comes out, and 2x plus 10 goes in, and that's equal to negative 2. We then are going to get rid of those brackets. So there's an invisible 1 in front of the brackets. That would be 2x plus 2x plus 10, and that's equal to negative 2. You'll always have variables that you could join together for substitution. So in this case, it's going to be x's. 2x and 2x will give us 4x plus 10 is equal to negative 2. And what variable are we solving for? It'll be x. Yeah. The only variable I have is x. What substitution does is it gets rid of one of your 2 variables. So we're solving for x here. So subtract 10 from each side, and you get 4x is equal to negative 12. Divide by 4, and you have what x is, negative 3. So we've only got half of it. We need to know x and y. But what you could do with this x is you could plug this into either system to solve for y. Which system do you think I would plug it into? Any idea? Look at this first one. If I plug it into this first system here, I put it at negative 3 here, and I do this calculation, I know what y is, right? So I'm going to take this first system, y is equal to 2x plus 10, and I'm going to take the x out, and I'm going to put in what I solved x to be. So that would be y is equal to 2 times negative 3 plus 10. Y is equal to negative 6 plus 10. Y is equal to 4. And that would be the solution. Your x is negative 3 and your y is 4. Let's look at the first class example. It says consider the following systems. What you want to do is you want to look at your two systems. One of the systems you could solve in one move. Like what I mean by solve is you could write one of the variables as equal to in one move. And what that would be this first one. In one move, you guys, I could get what x is equal to. Do you know what it would be? How would I do that? How would I get this by itself? You got to get rid of that 4y. So if it's a plus 4y, to get the x by itself, you would subtract 4y. Then what I've done is I've got x by itself, and that is equal to 17 minus 4y. When you solve for a variable in the first system, you can plug this into the second system, into the other system. So I have just solved what x is equal to. X is equal to this. I look at my other system and I say, is there an x I could take out and put in 17 minus 4y? And that would be right here. That x comes out and 17 minus 4y goes in. So it's going to be 2 times 17 minus 4y. There's a minus y in that second system, and that's equal to 7. Get rid of your brackets, and now you only have one variable that you'll be solving for. So you're going to have 34 minus 8y minus, that would be 1y, is equal to 7. The two terms that would go together this time is y. So that would be 34 minus 9y is equal to 7. There's two ways that you could solve it from here. You could either make y positive, or I'm just going to get rid of this 34. I'm going to subtract 34, subtract 34. I'm going to keep y where it is. So negative 9y is equal to 7 minus 34, which is negative 27. And then divide that by negative 9 and this guy by negative 9, and you have what y is. Y is equal to 3. You got to figure out how to get x now. So you got to say, where would I put this y? And there's actually 3 different places you could put it, and you get x, the same answer for x, but there's one that's going to be the easiest work. Where you would put this y would be this one. X is equal to, because we need x, right? If I put that answer of 3 right here, y is equal to 3, I just do this calculation, and then I will have x solved. So x is equal to 17 minus 4 times 3. X is equal to, and you type that into your calculator, 17 minus 4 times 3. X is equal to 5. And I'm just going to write that down with the y. We'll just do one verification for this lesson. In your homework, choose at least 2 to verify. But let's do the verification. Verify always goes into the original systems, not the manipulated systems. So the original systems were the following. The first one was x plus 4y is equal to 17. And the second system, the original system, 2x minus y is equal to 7. Take that x out, put in a 5. Take the y out, and put a 3. That's going to be 5 plus 12. 5 plus 12 is 17. And I need my two sides to match, and they do. is equal to the right side. It has to work for both systems though. So then you'd have to check this system. Because when we get to the real life examples, I will show you where it will work in one system and it won't work in the other. It's going to be like money questions. So this one, take the x out, put in 5. So 2 times 5 minus, take that out and put in 3. 10 minus 3, 7. Left side equals right side. Okay, flip your page. I don't like what they have for class example number 2. So I want you to write these two systems. Cross out, just put a line through the systems in number 2, and you guys put these two. You have a goal in this. The goal is to look at both systems and say, which system can I solve for one of the variables in one move? And one of these, I could do it. Raise your hand if you know. I want to see how many people know which system it would be. Like 8 of you. Okay. Tessa, what would you say? Which system is it? It's the first one. And what's the move that I'd have to make? Add 3y. Yep. Because if I add 3y, I've solved for x. X is equal to 6 plus 3y. I did that in the first system, so then the substitution is going to happen in the second system. So I look for x in the second system, which is right there, and this will go in. So it's always going to be get rid of your brackets, join your like terms, and then solve for the variable. Did you get -1? So double check. Oh, wait till you get to the end. Some of you might not be there. Okay, who got -1? Y is equal to -1. That's your answer. You have to then figure out, where do I put this -1 to get x? You got 3 choices. All 3 choices will give you the answer. 2 of the choices you're going to do a lot more work. So we need x. I've got choice 1, choice 2, and choice 3. Which one do you want me to choose? I'm not putting it in 2. You guys, what's the easier one? This guy right here. If I need x, just take the y out, and then I've got x is equal to, right? This is going to be the easier system, the easy one. So it would be this. X is equal to 6 plus 3 times -1. X is equal to 6 minus 3. X is equal to 3. So x is 3, y is -1. You could have put it, you could have put -1 in here, right? And you would have gotten the same answer. So watch, let's say I put it in this first system. What I would have had was x minus 3, y we got was -1, is equal to 6. And then this would be x plus 3 equals 6, right? That would give me x plus 3 equals 6. Subtract 3 from both sides, x is equal to 3. It doesn't matter what system you plug it into. Just one of them is always going to be the easiest. The hint that you want to do when you're saying, like, which system do I start with, is you want to look for a variable with a coefficient of 1. That's sort of your hint, right? So in this first system here, the x was the one that had the coefficient of 1. I just, in one move, would be able to solve for the x by adding 3y. Okay, let's try this last one. Get rid of class example number 3 and put this in. So this one has, I think, larger numbers. Raise your hand if you know which is the system that you could solve for a variable in one move. It's about half. Anais, which one? It's the second one. Yep. You could solve for this y in one move. Add 5x, you got y is equal to. You either have to get y is equal to or x is equal to, right? This is the one you want to use. Remember I said look for a coefficient of 1? It was that guy, right? So that's sort of a trick you could think of. So let's get rid of that negative 5x by adding 5x's. Now you have y is equal to 19 plus 5x. If you know what y is on this side, find your y in the other system. So y is equal to this. Here's a y. The substitution happens when I do that. I'm substituting this y for 19 plus 5x. What that would look like is negative 3x minus 8 19 plus 5x, that is equal to 20. Get rid of your brackets, join your like terms, and solve for the variable. So for these questions, I don't even bother here making the x positive, right? I'm just going to divide out a negative 43 at the end. So I just keep it where it is, and I'm going to get rid of that negative 152 by adding 152. And then you have negative 43x is equal to 20 plus 152 will be 172. And what is 172 divided by negative 43? Okay, x is equal to 4. Oh, yes, it is. Negative 4. What I did, we're going to figure out what y is. All of the questions that I chose for you for homework have nice answers. There's no decimals as answers, really nice answers. So if you're doing your question and you get something odd or a decimal, there's a mistake. Okay, so I purposely chose the ones that were integral answers, basically. Okay, find where you would put that x. Where would you put that x to get y? Julie, where would you put it? Yep, right here. That's where I would put it to. So I would take that x out because I want y now. Y is equal to 19 plus 5 times negative 4. Are you getting negative 1 for your y value? And there would be your two solutions. X is negative 4, y is negative 1. If it asks for an ordered pair, your worksheets is all going to just be ordered pairs. It'd be negative 4, comma negative 1. Okay, let's look at the homework. There's a couple questions all set up for you. So circle 1A, B, C, 2A, and 5. Go back to 1, question number 1, and I'll just make sure with A and B, you know what you're doing. So look at A. They have done the work for us. Do you see what they did? You always have to solve for one of the variables. They did that. Y is equal to. So they did the work. So what I would say is, okay, this is what y is equal to, right? That's the first system. I put that into the second system. So that's where it would go. And then you would have 3x plus 4. Y comes out and x plus 2 goes in, equals 1. Solve it when I give you the time to do the homework. Look at B. At first I thought both of these could be solved in one move, but actually only one could be solved in one move. The other one would take 2 moves. It doesn't matter. Like you could do either would be easy, but do you know which one it would be in one move? It'd be the first one, yes, because so we're going to get x in one move here. In this system here, if I wanted x by itself, I'd be subtracting 5y, and then I'd be subtracting 4. It's still easy to do this system if you wanted to. You could choose either system, doesn't matter. I'm going to choose the first system, and I'm going to say I want to get this x by itself, so I'm going to add 2y to both sides. And then I have x is equal to 10 plus 2y. X is equal to the 10 plus 2y. So you look at the other system and you say, I'm going to take out an x and I'm going to put in 10 plus 2y. So this x would come out and 10 plus 2y would go in. And then you'd have your 5y, you'd have your 4, and that is equal to 0. You'd be bringing your y's together and solving for y. Which system is it for C? First one, yep. When in doubt, look for the coefficient of 1. It's right here. So you say, okay, how do you get Q by itself? Subtract 4p and subtract 4p. That would give me Q is equal to 0 minus 4p, and I don't need that 0. Q is equal to negative 4p. So then you say to yourself, in my second system, you would take out the Q and you would put in negative 4p. Look at number 2a. I'll do this one with you, and the only reason why is it would actually be 2 steps. You'd have to get your variable by itself. They should be decent steps. So look at system 1 and system 2. Which system right away do you know it will be? It's going to be the second one, because I could get this y by itself, right? That's what I want. But it is a negative y. So that negative, like, because I want to solve for y, I'm going to make that positive. So the first move that I would do is I want that y positive. I'm actually going to write that 1/2 just as 0.5x. So 0.5x is equal to 3 plus y. Now that I'm making, but I get y by itself by subtracting 3. And then you would have y is equal to 0.5x minus 3, right? That's what y is equal to. It goes into the other system. You solve in one system and you put it into the other. That would be substituted there.